Today we're going to have a look at the next Ruby quiz, number 7, and I actually have no idea how I'm going to implement this one. I'm a bit stumped by it, to be honest, but all the more fun for you to watch, I guess. So, the task is here on the right. The task is, it's from a quiz show, and you get a number, you get a set of numbers and a target number, and your task, should you choose to accept it, is to use the set of numbers that you're given and use arithmetic operators like multiply, divide, plus and minus to reach the target number. And now I'm going to try to implement this in Haskell. There's a pretty good chance that I'm going to fail, but I'll put it up on the internet anyway, because what better thing to learn from than somebody else's failure. Okay, so if we go into pseudocode, then what we want to have is a function that we give a set of numbers, a target number, and it returns a formula. Okay, so let's put it this way. So a set of numbers, that's easy. A target, also even easier. But we can already see that the formula bit might not be so straightforward. So I have an idea how I could reach the right number, but that doesn't really allow me to see after the fact what the formula was. So I think what I need here is a data type term that I use to evaluate terms, which I can even print at the end. So we have the plus, minus, so we have the 4 operators, and of course we will need a number at some point. Okay, this is already going far into data type land. So what we're saying is a term can consist of those 4 operators, plus, minus, multiply and divide, or a term can be a number. Of course, here we can see that we also have brackets, and it seems that I haven't included the brackets in my data type, but actually there's always brackets, implied brackets that we have. So what we're building here is a tree, and the tree always has implied brackets. So I'll give you an example of that. So let's say that we have a tree that says plus let me actually do it the other way around. Mult plus okay, so what this translates to is 4 times 5 plus 7. So and we can also do it the other way around. So I don't need to put the braces into my data type because they're already implied by the tree structure. Of course, this depends how I'm going to do the evaluation, but we'll get to that one later. So Now the question is how now we can represent the formula, but how can we get on with things here? My idea would be to say generate all possible terms, filter for correct ones. So the idea is to generate all possible terms and then to take out all the incorrect ones. I think this should work, and what could be the case is that this is a couple of orders of magnitude too slow, but I still love to implement it because I think the best thing you can have is an easy to understand slow solution as a starting point to optimize. So let's have a look how we might do this. Let's just take the numbers here from the right. So just to play with, I'll put them here. So there we have our numbers. They're of type float. Why am I using float? Because just down here it says that it has to be that we can't use integer division, so we need some kind of fractional. So I could use double or float or anything like that. Actually, yeah, that's a problem. So float is not a good idea because I'm gonna have rounding errors. So let's see what I think the Haskell number types. Let's see what number type I want to use here. Let's go fractional numbers. So I want proper fractions. Let's see if I can find which one that is. Rational. I'm not sure. Let me just... Okay, so I'm going to use rational here. Okay, and now what I'd like to do is to generate the terms. Now, to be honest, I have actually given this some thought previously, because I just had no clue, and I haven't fully figured it out, but I think I have a good idea how I would do this. So what I want here is to generate all terms. The problem is that even though I have a limited amount of numbers, because I would construct terms of the form something plus something, what I was going to say was that, yeah, so that means that I'm going to use the plus here and then generate the something, and the something could again look like this, and then I expand this and it could be like this. So this could be an infinite regress. basically there's an infinite number of terms, even though it's limited by the numbers that I actually fill in. How I'm planning to go around this is by generating the terms in increasing order of length, of complexity. All of this sounds incredibly complicated. Infinite lists, the typical Haskell phenomenon, but it's actually, I think it's actually easier than it sounds. So, the shortest term that I can generate is one of the numbers. So, let's do that. That's that. And then I want to append to that more complex terms. So, how do I do that? I go into the So now I go into the list monad, and I say, look, I want a term, a left term and a right term, and I want them to have an operator. So let's do that. I want a right term. I want an operator. And I'm going to return the operator applied to left and right. Okay. This is, we're quite deep into Haskell territory, so I'll just do a short excursion. Let me just check if this compiles. Okay, let me just give you a simpler example to show. So here we have a simple example. It says, for x, pick one of the numbers 1 through 3. For y, pick one of the numbers 4 through 6, and then return the tuple x and y. And because we're in the list monad, it is going to collect all those tuples and give us a list of all the possible tuples with this combination. So if we go here into GHCI and I run tests, it gives me all the possible combinations of tuples. That's the list monad. Many different ways to write this. An alternative way to write this would be as a list comprehension. Let's see if this works, and it gives exactly the same solution. So that's basically what we're doing here. So what I'm saying is, I want to have the list of all numbers, and then I want to have the list of all terms. And I'm going to say, a term is an operator applied to left and right. Left is a term, right is a term, operator is one of these 4, and go. So what's going to happen here is that we jump into generate terms, and first it's going to give me the numbers. Here too, first it's going to give me the numbers. And then comes the plus plus, and then it will give me the terms. So this will actually, for 2 reasons, this will give me an infinite list. But it's an increasing order of length and complexity. I'm not using up the numbers as was the, so I can't use the same number twice. So I don't have to use all numbers, but I can't use the same number twice. So I haven't implemented that yet. But let's just give this a run. Actually, I'm gonna use less just less numbers as to reduce the length of the output. Okay, so let's see. Take 20 generate terms. Okay, let's set this to int just for now. Okay, so here it gives me, first it gives me the three numbers 1, 2 and 3. Then it gives me plus 1 and 1, minus 1 and 1, multiply 1 and 1, divide 1 and 1. So this is for 1 and 1 all of the operators. Then it's going to give me the next 4, and so on and so on and so on. And these terms are getting longer and longer, so now it's going through, let me see. Okay, so at this point here we have done all of these simple operations. So now it's going to enter more complex operations. I can see tiny problem coming up here. Let me just check something really quick. Could be that I never will run through these because this is an infinite list. So then I would have to come up with something else. I think I will fix this once I use the limited amount of numbers, but I just like to understand how this works. Yeah, that's what happens. Okay. Okay, so this is not generating all the terms because I'm stuck at tnum1. Okay, but this is still okay because I'm going to have a limited supply of numbers. So the recursion will stop there. Okay. And now we need to do one more thing, which is we need to take into account the numbers. Again, there's two choices that I could make. Could use the reader monad, or I can pass them around by hand. I'm going to choose passing them around by hand because working with I need to stack the list monad and the reader monad, and I just loathe the idea of doing that in front of an audience. So let's do it this way. Okay, so I pass it some numbers in, and now I need to, what's going to happen, I'm changing the type of generate terms. it's going to return the remaining numbers plus a term, plus a list of terms. Okay, so here we need to pass ns, and then it's going to give us an updated version. So the numbers minus the ones that have been consumed. So I put ns, and here it's going to give me another update on that. Okay. Okay, if I'm at this position here, I need to make sure that there is at least 2 numbers left. So what I'm going to do is I'm going to put a guard in here. I'm going to say make sure that okay, because we need 2 numbers to make this work. Simple as pie. Okay, so shall we give this a go and see what happens? Okay, so what we have here is that I haven't taken into account the whole removing of numbers. So let me do that right now. So I'm actually going to write a little helper function for this. Actually, I could write a helper function for both. I mean, obviously working with lists is incredibly slow, so we have one of the worst performing functions here. It's list concatenation. I'm just doing this now to keep things simple, and then I'm going to switch to sequence once this is running. So take a number means I'm going to take one of the numbers, delete it from the pool, and return it. Okay, and then make term is just what we had here. I'm making sure that there's at least 2 numbers left. I'm generating a term, choosing an operator and returning the result. Okay. So, because I'm threading through the state manually, there's quite a risk of making a mistake here. One very good reason to use the reader monad. I think this should be correct now. So let's see if this works. Line 17. Actually, this is not quite correct. I'm returning a list of terms and the remaining numbers. So, let's see. Wow, that worked. Okay, so generate terms. Let's give it a whirl. Okay, so far so good, but it actually crashed. Okay, so it gives me 1, 3, 5, gives me 1 plus 3, 1 minus 3. Okay, because this is really painful to look at, I'm gonna instance show term where show plus AB Okay, let me just make an unlines of that. Why? Now we're gonna map. Let's get rid of the remaining numbers. Okay, so this is what it gives us. I think it looks pretty good to me. Now we do a take 40. Okay, so this is what it produces so far. 1, 3, 5, 1 plus 3 minus 3, and so on. Okay, looks pretty good to me so far. The only thing that I'm missing is something other than 1 in the first position. So there we still have a problem. Okay, so the problem is I'm descending further and further. So let's say ns is greater than 2. So it jumps into generate terms, checks, still greater than 2. Jumps into generate terms, still greater than 2. So there we have a problem. The problem is that we're going deeper and deeper into recursion, even though we don't have enough operators to work with. So I need to take that into account. So I have. Let me just think for a while here. So I need to, before I recurse, I need to check that I have enough operators to fulfill this. How would I do this? So before I call this, I need to make sure that I have enough numbers left to even go in there, because otherwise so this doesn't work. You can always take a number. That's perfectly fine. The problem is make term. Here we need to check what's going on. How am I going to do this? I could log the recursion depth, but that would be an evil solution. Let's have a look at those solutions again. So he has used up everything. He took a number and now he's right recursing. So here he took the first possible value, which is 1, and here he's going through all the possible combinations of 3 and 5. So he's exhausting this. No, that's not true. He has already exhausted that, and he's now exhausting left take number, right take number. And when he has exhausted that, he goes to make term. It creates a completely new term. So the take number case, that's easy. If I have an empty list here, that shouldn't do anything. So here already we have a problem. Because he jumps into the make term. If we take this out, then this terminates. But instead he goes in here, generates a term. These won't work, so he goes into a make term. And then he's in here, this won't work, so he goes in here. So that's actually the problem that we have. Okay, I don't really have a better idea at the moment than to pass in the length of numbers. And whenever we call make term, we call this with L minus 2. Not a beautiful solution, but it will do for now. So what I'm saying is I'm passing in the length of the list and the list, and then I use this. So if the list is empty, then this fails, I get the empty list back. Then I go into here. At first the list has, let's say, 6 elements, so this one's fine, and this one calls well, or I don't know, at least with -1. So when this must at least be a take number. Yeah, I'm not very happy with this solution. Let's see if it works. So I still have to have the empty list. Okay, I need to pass in. So empty list. That works. Let's take my original numbers again. So what's the issue here? Just do this. So how long is this? Let's just run this. Use 3. Okay, fantastic. So, I think this should be all the terms that I can build with 3 numbers. Don't know what the problem is here. Generate terms. Lengths. Okay, so the idea of this is to generate all possible terms. Okay, so now I have a couple of challenges. Or some things to. So I've ticked this one, generate all possible terms. But what I haven't ticked yet is that I need to evaluate my terms, because I've chosen a data type here. It's not really an equation, so I need to evaluate. Okay. We say evaluate tnum a. Okay, why is there no division? Maybe it's div. So let us evaluate. Okay, I'm saying multiply 4 times in braces 3 plus 2. So this is 5, multiplied by 4 is 20. Okay, fantastic. And now comes the moment of truth. Now we will see how horribly slow my solution is. Okay, so I generate the numbers, and now I filter by predicate, and I take I run the numbers, and the predicate is that I get a term generate all terms, and I filter by that the evaluation of t is equal to the target. And let's see what happens now. So generate terms is a list of tuples. Ah yeah, sure. So numbers, and the target is 522. Divide by 0. Very good. So I can't divide by 0. So I'm saying guard. So I'm saying make sure that we don't divide by 0. Actually, probably this is the wrong place to do this. So let's just remove all of this. And I'll actually put that into eval. Can I do that? I'll have eval return maybe. Okay. Okay. So now I say eval is of type maybe untype. Term. Okay. 25. Okay, because now those are maybe values, I can't just add them. So one thing leads to the other. Okay, my goal had been to do this really fast. Obviously that's not happening. And I still have the good chance that the whole thing will be too slow and that I need to do something entirely different. Okay, the question is, where is the problem here? The one thing I wanted to check was how many terms are actually being produced at the moment. Let me just see. Generate terms. A lot. Okay. Okay, so now let me just see if I can test this somehow. So I want to check how to get with So, but already here we can see that there's a lot of things that I don't need to do. So what I'm actually going to change is this make term. I'm going to change that one. I'm going to say pluses, minuses, mults, divs. Gonna add a new function. That one's going to get args. I'll just start with the pluses. Oh, I'll have to do them anyway. So, pluses. The problem is that my whole approach doesn't really work. Let's see. Let's see how this goes. I'm really annoyed that it has taken me so long, but this is how it goes, at least for me. I mean, probably there's some other people who can work this out in just no time at all, but not me. Now we can actually undo this whole thing. Problem is, I might be evaluating things multiple times now, but we'll just see what that. So we're going to say guard left, evil left, and evil right. It's not 0. Because 0 plus x and x plus 0, they're not helpful. Here we're gonna say guard evil right is not 0. Here we're gonna say we don't want to multiply by 1. We don't want to divide by 1. We don't want to divide by 0. So now we have generate terms. Let's see. This is a div. While it seems expensive to filter these things, to evaluate all these things all the time, it actually saves a lot of time, because there could be all kinds of things coming behind what we evaluate. Still very long. Okay. Okay. So we don't want to divide by 0, we don't want to divide by 1, don't want to multiply by 1, don't want to subtract 0, don't want to add 0. Okay. I think I'll have to tackle this whole issue a little differently. So what I'm actually going to do is to change the way this is evaluated. I'm actually going to add a num type here. Okay, so just to explain what the plan will be is, I will evaluate things from the start. So what that means is that as soon as I construct one of these, it will already be evaluated. That's gonna give me a couple of advantages. Okay, the only thing that this means is that I won't be using the constructors directly, but that I will be using special functions that construct for me. So what I'm saying here is if I want to construct a plus, so it's a plus AB, and I'm already calculating the value. And for completeness, I'm gonna okay, so obviously that doesn't help me one little bit yet, but let's see if this compiles. Okay. I can actually call this even more. Okay, so that's already working, and now I think we have all kinds of opportunities, because now we can say we can have cases. For example, here we can have a case that we have 1 plus 2 and we have 2 plus 1. The way we would usually I would usually solve this is to say that the first parameter has to be greater equal. And the same goes for multiplication, that's also symmetric. Okay, let's see. Okay, so So it just needs to think really long. Okay. Let's check this one out. Still too many parameters. Okay, what else could I look for? I think I'm going to sort the array. Okay, let's run this with 1, 2, 3, 6. One plus 2 minus 3. That's very smart. Actually, we can say that it needs to be strictly greater. Okay, this is looking much better. Okay, there was a couple of suggestions in the Ruby quiz here. We've done this one. Maybe there's something about symmetry that I can do for the divs. But maybe this already helps us. Okay, so we have at least one solution. Okay. Let me just see if this works out. Okay. Okay. I wonder if I have... I think I set it to int, not rational, so there was some rounding. Okay. Let's test this. Very cool. Works. Oh yeah, the problem is that I'm still using both 5s interchangeably. So I don't really know how to fix that at this point. There's 2 5s and they get treated fairly by the list monad. Yeah, I guess that's okay. Okay. So this has taken long, much longer than I had hoped. I hope you enjoyed it, and see you next time.